Now, here's a bit of a trick question here. When you get a ratio, right? Like we've seen examples where we start off with the question and then you have to figure out the simplified ratio from that, right? The 5 to 2 to 20 actually started out with quarter to dime to loonie, right? Let's say our simplified ratio, we know at the end here, it's telling us the ratio of Matthews to Daniels on a baseball team is 2 to 3, like that. And it's asking us, how many Daniels are there? Well, you might look at this and say, well, the Matthews is 2, so I know it's, they were trying to trick me here. They're trying to get me to think that the Daniels would be the 2, but no, Daniels is the second one, so I bet it's 3. But 3 is actually the wrong answer here, as I think a lot of you would know. It's that it's actually impossible to know from the information here how many Daniels are there, right? Like let's say there are 15 guys on the team, right? Let's say you have 9 people on the field, a bunch of people in the bullpen. Let's say there are 15 players on the team. If there's 15 total players, it could be that you have 2 Matthews, 3 Daniels, and 10 other guys. Like this part of the ratio you wouldn't need to show for this question, but I'm just adding it on. 10 other guys who aren't named Matthew or Daniel. Or alternatively, it could be that you actually have 4 Matthews, 6 Daniels, and 5 other guys. Or it could even be that you have 6 Matthews, 9 Daniels, and no other guys. So it's possible to have 6 Daniels. It's possible we saw before to have 3 Daniels. It's possible to have 9 Daniels. Since there are 3 possible answers, it's impossible to know exactly how many there are here. So that's just to remind you that when you're given a simplified ratio, it doesn't tell you the actual number of how many there of each thing there are. It just tells you the relationship between each other. We know that however many Matthews there are, the ratio of Matthews to Daniels is 2 to 3. Could be that it's a giant baseball team. There are 20 Matthews and 30 Daniels. That's possible. I mean, I don't know why that would happen, but it's possible. Okay, a ratio is a simplified version of the relationship. It's not the exact numbers itself. All right, next thing for you to know is the difference between a ratio that is 1 part to the total, which is probably what I would say you're most familiar with, to 1 part to another part. And I say you're most familiar with this type here because whenever you get a test back, like let's say you get this, like your teacher's written this on the top, 4 on 10, like that. You're like, 4 on 10. That's like I got a 40%. That's a failure, right? 4 on 10, that's a ratio, and it's implicit from your teacher that the ratio here is number of questions right to total number of questions. That's 1 part, the part you got right, to the total, 4 to 10. What the teacher doesn't mean, you don't see a teacher giving you like a ratio of like this. Like if a teacher wrote, let's say you got 4 out of 10 on the test, and so your teacher writes a ratio of 1 part to another part, the part of correct answers to the part of incorrect answers. They gave you 4 on 6. You're like, oh, that's 67%. I passed. I thought I did really bad on that test, but I guess I got a 67. Hooray for me, right? This ratio is a little unfamiliar to us if we're talking about marks on a test. So 1 part to the total, notice that the 4 questions you got right are actually included in this number 10 here. Whereas in this version, the 6 is just the answers you got wrong, and here the 4 is just the questions you got right. So these are 2 different types of ratios. Depending on what we're looking at, you might be asked for one, you might be asked for the other. Like let's say we've got a baseball team, there's 6 right-handed batters, 8 left-handed batters, and no switch hitters. If the ratio question is asking what's the ratio of right-handed batters to players on the team, to total players, well, the right-handed batters is 6, but the total players on the team is these 6 guys and these 8 guys together for 14, right? I would reduce that ratio to 3 over 7. I could also have been writing it like this, 3 to 7, or with the word 2 in between, but the answer is 3 to 7. The same question, if it's saying, what is the ratio of right-handed batters to left-handed batters, then the number for right-handed batters is 6, just like it was before over here. But the number of, the second number here isn't total batters on the team, it's the left-handed batters. So it's going to be 6 to 8, which I would then simplify to 3 to 4. Notice that in this one over here, the 7, this includes this 3 in it. Whereas over here in my answer, the 4 doesn't include this part in it. This is a part to the other part. This is a part to the total. Okay. Let's see. I think you guys can handle that on your own. And I know in rates, there's one big thing I wanted to talk to you about rates. We already talked a little bit about it, that rates are relationships between two unlike quantities that involve units that can't be converted into the same units, right? So if you have unlike quantities, such as dollars per person, right? You can't grind people into pennies or whatever it is, or dollars and hours, people say time is money, but they don't actually mean that, then you're going to be dealing with a rate. If you have unlike quantities, you're dealing with a rate, and you express it as a fraction. Sometimes we use a slash to write it like this, 12 kilometers an hour, but this slash really is just a fraction written in kind of a lazy way. This is really writing this here in the same way. And the piece of information that I want to make sure you include on your page of your unit book for this is when it talks about this here, simplified rate making the denominator equal to 1, this is a term I want you to know, and there'll be questions that I'll ask you to fill this in, that this is what we call a unit rate. It's a rate per one of something, a unit rate. So for example, down here, when it tells you that in a pie eating contest, let's get a pencil going here. In a pie eating contest, Ryan ate 4 pies in 20 minutes. To get a unit rate out of this here, this is a rate. To get a unit rate, we need it not to be per 20 minutes, but we want it to be per 1 minute, or per 1 hour, or per 1 day. Just per one of something makes it a unit rate. So you start off, okay, I got 4 pies. I've already decided pies are countable things, minutes is time. They're unlike quantities. This can't be a ratio. 4 pies for 20 minutes. I'm going to write it in a fraction because rates you always write in fractions. And then I say I want to get it to be per one of something. I'm going to get it to per 1 hour. It's not the only way to do it, but it's what I'm going to do. So I'm going to multiply it by 3 to get 20 minutes to turn into 60 minutes. And then I multiply the top by the same thing to get 12 pies per 60 minutes. That's too much pie eating, but there you go. Unhealthy food attitudes recommended in math class. Sorry about that. 12 pies per hour. Ran out of space again here. So 12 pies per hour. That's per 1 hour. But if you don't write the 1, I'll understand. That is a unit rate. Again, I could have said, let me, instead of converting it to 1 hour, let me convert it to a unit rate that gives me the total number of pies per minute, per one of something. As long as it's per one of something, it's a correct unit rate. So 4 pies per 20 minutes, if I want to convert this to per 1 minute, then I've just got to divide the top and the bottom by 20. And when I'm dealing with unit rates like this, this means that sometimes I'll get non-integer values for my rate. And that's okay. That's acceptable in unit rates. So if I divide 20 minutes by 20 to get to 1 minute, I divide 4 pies by 20 to get to 1 minute. And 4 divided by 20 just gives me 0.2, not minutes, 0.2 pies per minute. Okay. All right, and the rest of these are examples, but you see here you have some assistance for the Mateo Martinez method. Always remember to use that when necessary. But let's actually figure out a few of these here. So these are some ratios questions. Let's see if you can figure these out. Write the ratio of the time in 2 hours to the time in 3 days. So I start off 2 hours to 3 days. Then I'm going to get them in the same units so I can cancel the units out. That's 2 hours to 72 hours. Cancel the units out. 2 to 72, that's a fraction I can reduce. 1 to 36, that's my answer. That's how you show your work for this, right? Write the ratio